Good day. Today we are going to talk about linear regression and neural networks. When we have data and more data, we want to find patterns between the data with we are working. A good starting point is to visualize our data to find if there is a visual pattern in the data. And sometimes we can see such things like linear patterns. To start, we need to talk about what is a linear regression. A linear regression, simple or multiple, is a method of data evaluation and modeling that establishes linear relationships between variables that are dependent and independent. It is relevant to note that independent variables are correlated with dependent variables through an equation. The most basic case of linear regression is the simple linear regression. In this case, there is only one independent variable. Suppose that we have a data set with a linear distribution. We can think that the best way to model the data is with a linear equation that fit to the data. In the case of multiple regression, we have more than one independent variable. To make simple, suppose that we have two independent variables related to the dependent variable, and the equation that best fits the data is the equation of a plane in three dimensions. So, equations of the following form describe the best fit equation according to the data. One good metric to measure the performance of the model are the residuals, also known as errors. And there are two main equations that can help us in this task. First, we have the mean absolute error that make an average of the distance of each error, how far the predictions are from the real values. The other metric we can use is the mean square error, that make the square of the distance of the errors. This makes that larger errors become more relevant. Okay, so we have found a way to find equations that represent linear data and can help us to predict more data that follow these equations. But what happens when the data that we try to model is not linear? Here, the neural networks enter to the arena. Neural networks. According to Jeroen Aurelien, a neural network is a machine learning model inspired by the networks of biological neurons, where the data enter to the network and turn on different neurons inside a network that produce one characteristic output. Because of this algorithm can help us to classify between nonlinear data. As their name suggested, neural networks are composed by neurons that are a mathematical representation of the biological mechanism of a neuron in the brain. Here, a sort of input enters to a weighted sum, and after they pass it through an activation function, we obtain an estimation. This last value can be pasted to a following neuron or can be used as a prediction. Here, we aren't going to enter in many mathematical details of the artificial neural networks, but it is relevant to notice that the function sigma, the activation function, is a nonlinear transformation that turns on or off the neuron according to the result of the function. The most popular is the ReLU function, but also we can find another relevant functions as the sigmoid. To understand how neural networks works, suppose we have images of cats and dogs that we want to classify. Each image is going to turn up some neurons patterns inside the artificial neural network, and this leads to an output response in the output layer, in this case, cat or dog. To measure the accuracy of a prediction made by the neural network, we can use the cost function that make an average of the loss functions in the neural network. The loss function makes a measure of how distant the predictions from the true value are. After obtaining the cost function, we want to decrease that value, and this can be made using the gradient descent algorithm. This algorithm searches for the minimum in a plane. To conclude, we can remark the highlights of these two algorithms that we saw in this video. For the linear regression, we have that this is a useful model for linear distributions. fits the data to a linear equation, and their popular metrics to measure error are MIA and MSA. For the neural networks, we have that they are useful for nonlinear distributions. Also, this is an algorithm that searches for the set of functions, in this case the neurons, that minimize the error. Before I finish, I left in the description of the video two Google Colab notebooks with exercises related to this video. The first one is a linear regression solved with the least squares method, and the second one presents a neural network to distinguish between dots in two circles. Without nothing more for the moment, thanks and have a nice day.